All right, so in the Super Bowl, by how many points does the winning team outscore the losers? Here are the winning margins for the first 25 Super Bowl games. So on your calculator, hopefully this isn't dead. Okay, great. Sometimes it's better with the light on and sometimes it's better with the light off. Okay. All right, so, well, the only thing is it's going to have a glare on the actual calculator, but at least you can see the screen. So what you're going to do is we're going to type all these numbers into a list. So, here, one second. Let me write it down first so that way y'all have it. So you're going to be looking for stat, okay, so that should be on your calculator near the arrow buttons. And then you're going to click that. You're going to click edit. And then enter data into L1. Okay, so that's list 1. So I'll show you what that looks like. Do I have an extra one? No, but if you want to, well, I can put it up here and then you can actually try it if you want. I'll show you how to get there really quick and then I'll let you type it in. All right, so you're going to hit stat and then edit. And then I have a bunch of numbers in here, and so like there's 15. So you can either overwrite them or you can just clear the list before you start. But you would just start typing in the number and just hit enter after, and then it's going to just come up. So I'll let you type them in. So just type them in order. I usually like to go back and look at my list once I type them to make sure I typed everything in correctly. Because on occasion you hit the wrong number or something like that, you know. Yeah, well, and the nice thing is when you type them into the list, it'll tell you how many you've typed in. Yeah. So like in this case, you're told that there's 25 Super Bowl games, so you should know that there's 25 scores in that list when you type them in. So y'all have them all in. Okay. So then now it says to find the median, find the quartiles, and then write a description based on the 5-number summary. So that's actually going to be something written in words. But to solve the other two things, your calculator will actually do that for you now that you have your data here. So you're going to hit second and then quit to get out of the list that you're currently in, but it'll save the data there. So then next you're going to hit stat. And then there should be a button or a thing you can arrow over to that says calc. And then arrow down, and I don't remember what number it is off the top of my head, but it's going to say 1 variable stats or 1 VAR stats. Oh, perfect. There's so many functions on there that we use, I never remember which one's which. So if you hit that and then you hit it, when you click enter, it may bring up some information that it wants. So it may ask you for like your data list. I'm trying to remember what all it asks for. So your list is going to be your L1, which is already there. If it's ever not there, then what you do is you hit second stat, and it'll bring up your list options, and then you would just click whichever one it's in. The frequency list, you can try without putting something there. Sometimes it makes you put something there, but usually it'll work without it. and then it should just be hit like calculate. So then it should bring up, it should say something like your min value, your max value, and then it probably says Q1, Q2, Q3. Some calculators, instead of Q2, it actually will say median. And so, depending on what your calculator says, your Q2 value is your median.
17.
And so that's going to be 17. If you want to put units on it, it's in points. And then your quartiles, again, I'm not 100% sure. It may also say something like 25% and 75%. But what you're looking for with this is your Q1 and your Q3 value.
6 is Q1, and then Q3 is 21.5.
Okay. So the nice thing about this section is that right there pretty much gives you the answer to most of the problems that you're going to have. As far as then the write a description based on the 5-number summary, the things that we didn't write down, so what is the min and the max?
1 is the min, and the max is 45.
Okay, so 1 and 45. So we're going to want to comment about that when we, in words, write the 5-number summary. Sometimes it'll just say list the 5-number summary, and so you just write all 5 things down, basically like this. Or like write them in order like we did in the notes the other day when we were drawing the picture of it or whatever. But when we write the description, we're going to want to talk about the min and the max. We're going to want to talk about the median, which is the middle, and then we want to say that the middle 50% won by this many points, and so that's going to be the difference between your Q3 and your Q1. So something like the fewest number of points, and you can abbreviate stuff too. A team won by was 1. The most points was 45. Based on what we see in the data, you could potentially comment that 45 may be an outlier, just because it's significantly larger than the next largest number, but without running some calculations that we'll learn again later, we don't know that for sure. So if you didn't comment about it right now, that's fine. Once we know how to tell if something's an outlier, then you would need to. And then something about the median number of points. Was 17. And then say something along the lines of the middle 50% of teams won by 6 to 21.5 points. Okay, and obviously in football there's not half points. Well, I don't think there's half points in any sport, to be honest with you, but unless you go to like wrestling or something like that, I don't know. I don't really understand how that works, but regardless. But don't round, even though that's not realistic, because we're just talking about like that, like average range of what those points are, kind of. So anyways, so when it says to write a description of the 5-number summary, it's kind of just like write out the summary in words. So it's kind of tedious and annoying, but it's not really hard. Kind of some easy points to get. So all right, so for the next one, you need to input that data into the list as well. There's less numbers, I think, in this list 1, 2, 3, 4, 5, 6, 7, 8. So yeah, there's 16 numbers. So there's going to be less than what you had in the list. So you have the couple options here. When you hit stat there's an option that's going to come up and you'll see it says clear list. You can click that, and then you can hit second stat, which brings up the list, and then you can do the L1 like you typed in to get your one variable stats. And then you just have to hit enter and it'll tell you that it's done and the list is cleared. Or you can start typing over the list, and then when you get to where you're have extra data, you can hit the delete button and hit enter and just keep deleting them one by one. So if you just had like 1 or 2 numbers extra, I would just do that. But since this one has 9 extra numbers, I would probably clear the whole list at once. It's just easier. So you can type all those in. Make sure you pay attention to decimal points. This is one of those where it's really important that you check and make sure you typed things in correctly, because if you happen to leave one as like 227, it's going to be really unfortunate. Those gas prices looking nice right now.
I was like, I wish.
Remember the days when it didn't cost $100 to fill up my car. And I just wrote out the thing of how to do the clear list in case you like to write down what the calculator steps are. I always like to see what they actually are written out, so. And so again, if we wanted to, we could run the one variable stats and do all of that. We don't have to for this particular situation. Well, I guess technically eventually we will, but we don't need to do that yet. So it wants us to make a histogram of the data. Again, this is something your calculator can do for you. So I'm going to write out the steps and then I'll walk you through actually doing it. Once you have the data in the list, you're going to hit second, and then you're going to hit the Y equals button, and that's going to bring up something that says it has all your different like plot options, and it's going to have plot on, plot off, something like that. You want them to be off unless you're actually using one of them at the moment. And so you're going to want to turn a plot on. So I usually just use the first one. Sometimes I question why they have like 4 of them, because you typically only are using one of them, but you know, whatever. And then the Y equals at the top left. And so then you're going to select the histogram. So there's a couple that kind of look like a histogram, but I think the histogram is the very first one that you click on. It should, I mean, you should kind of know what a histogram looks like, so it's that one. And then, Joelle, your calculator's probably going to ask if you want it in color. Mm-hmm. Mine doesn't. So then you're going to hit zoom and the number 9, which is zoom stat. So whenever you're graphing any kind of a stat plot, you're going to always hit zoom 9. In most other classes, we hit zoom 6, which is zoom standard. And so if you hit one of the other options, not that you won't get the graph, but it might not look right. Because zoom stat is going to take the information you gave it and use it. Now, it probably asks for a data list, I'm guessing. Did it ask you for a list when you were on the plot? It probably, as long as you're using L1, it should always be set for you.
Yeah.
Sometimes it'll ask you for the variable. I can't remember exactly, but it's just X if that asks for that. So you should get something that looks kind of like that-ish. Something. So what I always say is, so that it is always consistent, hit zoom stat and then draw it exactly as it is on the calculator. And then that way it's consistent. And we'll talk about with the part 3 of this question in a minute what can sometimes be different about it. What? So if I have something in y equals, it's also going to look funny. So if you ever have something stored in your y equals, then, okay, so you have that one. Oh, wait, and so then hit zoom, and then number 9. You should hit number 9 on your calculator and it'll pop up. Oh, let me see. There's probably something in y equals. Yeah, there is. That's fine. Oh. Multiple plots are on. That's why. This one off. There you go. If more than one plot is on, it'll tell you that something's not right. So. So anyways, so when we get to part 3, I'll show you what's a little different. So don't like completely get, well, if you just hit the graph button again, it'll just pop back up for you. So then it says to describe the distribution, shape, center, and spread. It's going to be a tongue twister. So what is the shape of this? Right skewed. Okay, so it's skewed right. And what else is it? So how many like big humps does it have in it?
Oh, it only has one.
So it's going to be right skewed and unimodal. Now, for center, what it's wanting you to talk about is what the median is. Okay, it's skewed, so we need median. So what you're going to do is you're going to go back and you're going to do your one variable stats again. So stat calc, one variable stats. 2.275. And just because it is money, I just put the dollar sign on it, but obviously they weren't on those, so it's not a big deal if you put it or not. All right, so then we want to know, basically when it's asking about our spread, we want to tell them what the spread is / the center is, because it's kind of a mix of both, between our Q1 and our Q3. And we're going to tell you that that's where most of our data lies. And then we're going to say what the min and the max value is. So most stations charge between and this is just going to be your Q1 and Q3 value. So what is Q1? 2.25 and Q3? 2.35. So then the other stuff is the min and the max value.
Min is 2.21 and max is 2.46.
And so that's enough to talk about what's going on there, what it's asking for. In the next chapter or whatever, that sometimes they have its own question for like what are the outliers with that, because obviously it's part of SOX. Since we haven't gotten to actually knowing yet, the next question is saying, what unusual feature do you see? Are there gaps or outliers? Okay, so what I want you to do is I want you to hit, I think it's window at the top of the calculator. Is that a button? Mm-hmm. Okay, so then there's going to be something where you can change the scale. I want you to change the X scale from, I don't know what it is currently, but I want you to change it to 0.03. And then hit graph.
Oh, there is one.
Did it work?
Yeah.
Okay. So when you change the scale to 0.03, we see a gap in the distribution. And that's that no station charged between $2.40 and $2.44 per gallon. And so you can also see that just by looking at your data up here, but obviously it's a lot easier to see on your calculator. So it's kind of a matter of like breaking it down into smaller sections. Do you know what was the original X scale? Did it say what it was?
0.05.
Okay. So when you went down to 0.03 and you made the window of it smaller, that's when it allowed that to happen.
How did you know that there was no charge between them?
Well, you can look up here and see that there's nothing in that area.
Okay.
So it was like you have a 2.38, and then, well, there's no 2.39, but that's probably included since you're going every 3. And the first one is 2.21. So it's increments of 3. So it would have been at 0.39 would have been included in the last one. Now, obviously, 2.43 and 2.44 would technically be in the next window, but it was more so just, or in the next bin on the thing, but it was more just commenting that there's not one there. So, if you couldn't tell like exactly what it was, like if there's like a really big list of numbers and you couldn't tell exactly, you could just say that there's a gap in there, and you wouldn't have to tell exactly what it was. This one, just since there's less numbers, you could actually semi-quickly look at it and see where the gap is. All right, any questions about either of those two at the moment? Then, let's see, next page. All right, so these ones, sometimes it depends how you look at them, to really know, what they are. And actually this problem, just in case you're looking, is number 6 in the book. Anyways, just more of an FYI. All right, so would you expect these distributions of these variables to be uniform, unimodal, or bimodal, and then symmetric or skewed, and explain why? So we'll just talk about why, and we'll draw a picture of what we think each of them look like. So for the first one, ages of people at a Little League game. We think uniform, so like straight across the board. Unimodal, so where it's just got the one hump in it, where it's kind of like most of the data lies in this one big section. Or bimodal, where it's a lot in one area and then goes down and then a lot in another area. Uniform? Why is that?
Because everybody's the same age.
What do you think, Joel?
I was gonna say bimodal, but
Why would you say that one?
well, because like I don't know. I literally have no idea.
It's like the same age group.
Yeah, that's true.
Well,
I don't know.
so it says ages of people at a little league game.
Yeah, because
Doesn't necessarily just mean the players.
Yeah.
Oh.
So that's why I said sometimes it depends on how you read the question. So when you get a problem like this, like on a quiz, test, something like that, or even in your homework, when you explain why, the book is going to say that the answer is this. And they're going to tell you why. But if you tell me it's uniform because all the kids playing are pretty much the same age, or you have the same number, you know, if you have a 10 to 12-year-old league, you're going to have probably a relatively even amount of 10-year-olds, 11-year-olds, and 12-year-olds, more or less. If you explain that, that would be a sufficient reason, and you could say that it's uniform. If with bimodal, which is what I would think of, is you're going to have young kids probably, so you're going to have that one hump in the lower age, and then you're going to have your parents who are older, so there's going to be a gap in the middle, and you might even have grandparents that could even make it another level of that. But as long as you explain why, it's fine. And you don't have to like manually draw out the little things. What I normally do is I just do something like this. And just kind of draw it out like that. The line going out to the right is kind of just the potential grandparents that might be there, or something like that. So I would say bimodal, and then is this symmetric or skewed?
Skewed to the right.
Yeah, skewed right. All right, so then B, the number of siblings of people in your class.
That's so weird.
So, like, if, well, let's see, Joel, how many siblings do you have?
I have 3.
3. Do you have any siblings? You've 1. Okay, so last year we did this, and so a couple people, let me see. 1 person didn't have any. 2 people had 1. 1 person had 2, and then the other one had 4. And so we used the 1 and the 2s and the none to do the first part. And then we said, well, there's a few people out there, you know, like the 20 kids and counting or whatever it is that have like a ton of kids. So if you think about that, what do you think the shape of this is going to be? And then is it going to be symmetric or skewed?
I really want to say uniform, but like it also wouldn't make sense. I don't know, because like it could also be bimodal, because you have like a lot of people have like 1 sibling or 2 siblings, but then there's like others that like don't have any, and then there are others that have like a ton of siblings. I don't know.
So
I wanna say bimodal again.
So I would say it's probably unimodal, but very much heavy on the left side, where you're in like the 0 to 4 siblings area. And then you have those few people that have like, you know, 12 siblings or something like that. Like that just sounds like a lot of work. But so I would say something kind of like this. And then, not a guarantee, but you could say that it's probably skewed right. Because I think having a few siblings is more likely than having like 12.
Yeah.
But you do have the occasional family, you know, that it's a little harder in a class of 2 to really like get the data. Ideally, you'd do it over a class of like 20 and see what actually happens. But that's one where you could argue it different ways. I would still say it's probably going to be unimodal, regardless of how you look at it. But, you know, and if you had 20 kids in your class, there could be an even split of 0, 1, 2, 3, and 4 siblings. There may not be anybody that has more than 4, you know. So, like, you could argue, well, it's uniform. So without some data, you wouldn't know 100%. That's why it's really big on explaining the reasoning that goes with them. Okay, the next one is pulse rates of college-age males. So heart rate, basically.
I'm not a male, but we still look at my rate. 89. I feel like it would be between, like, I would say uniform. But also you have to, like, consider that, like, some college-age males are athletes, which means that they could have a lower heart rate.
Well, and it depends on when you look at it, too. If you're looking at it when they're working out,
That's
or
also true.
somebody that's lazy and sits on a couch all day, or...
I was thinking it was like arresting.
Yeah. I think it would have to be a little bit more specific to know for sure, but if you looked at resting, okay, most people's resting is probably, I think we actually looked this up last year. I think it said that it's between 40 and like 80.
Yeah.
I think was like the typical range. So knowing that, what do you think it's going to look like? Uniform?
Or unimodal. I'd probably say unimodal.
This is another one where last year we modified the question a little bit, but we tried to figure out what everyone's was. So I think you could make an argument for uniform or unimodal. I tend to go toward unimodal because you probably don't have a ton of people that have a resting heart rate of like 40, and you probably don't have a ton that's up at like 80. You probably have a decent amount that's in that like 60 to 70-ish range, somewhere in there. So I would tend to go unimodal. Whoa. Well, good enough. And it would be symmetric, I would think. I mean, relatively speaking, again, you have a college that has a ton of athletes, or you have a college with very few athletes, you know, obviously the other things, but. All right, so the next one,
Oh my gosh. It's like,
the number of times each face of a die shows in 100 tosses. So if you tossed a 6-sided fair dice 100 times, and you were to write down every time it lands on a certain face, what would that shape be?
Let's say bimodal. Because it's gonna be all over the place.
I would say uniform, because like if you have 6 sides and you toss it 100 times, it'll probably be like relatively the same.
So in theory, if I said,
I mean,
what's the probability of throwing a 3 on a 6-sided dice? What would you tell me the probability of throwing a 3 is?
1 out of 6.
1 out of 6, okay. What about throwing a 5?
1 out of 6.
Okay. What about throwing a 1?
1 out of 6.
Okay, so what would that make you think would happen if you threw it 100 times?
They'd all almost have the same chance of getting the same.
In theory, they should. Now, we know that that's
That's
not
not probably
always true.
Yeah.
Seems that inevitably it always lands on something different, you know, than what you actually are hoping to see happen. If you roll the dice 6 times, you're probably not going to see a 1, 2, 3, 4, 5, and 6. You're probably going to see something on repeat, and 100 doesn't evenly divide by 6, so there's also that. But this one would probably be uniform, or at least relatively speaking, would be uniform. So, something like that.
Or is there not?
We usually don't say anything if it's uniform just because it's the same. I mean, it's pretty even across the board. All right, and then another note thing that I always forget to actually add to the notes here. If you have something being skewed right, we say that the mean is greater than the median. If it's skewed left, the mean is less than the median. And if it's symmetrical, they're equal. Or approximately equal. So if you always remember that mean goes on the left side of the equation, then you can think that left is less. So if you always remember that mean goes on the left side of the equation. Do y'all feel like you need to see any more examples, or do you feel like you're okay with that?
I think it's pretty straightforward.
Okay. I do have a few more that I can work if when y'all do the homework you're like, yeah, I'm confused. So the problems, I'll just write them on here. Not a ton this time. 5, 7, 11, 17, 19, and 47. So there's that.